Every spring, American gardeners pour billions of dollars into bags of fertilizer and then pour something far more valuable straight down the kitchen drain. The cloudy water you rinse off your rice, the starchy grains stuck to the bottom of the pot, the bran swept off the mill floor and sold as animal feed. For thousands of years, farmers across Asia used these exact kitchen byproducts to build some of the richest, most worm-dense soil on the planet. The soil amendment industry, worth over $200 billion, would prefer you keep buying their products and keep throwing away the one ingredient already sitting in your pantry. The record opens in the Yangtze River Delta, more than 6,000 years ago. Archaeologists excavating Neolithic settlement sites found buried rice paddies, preserved layers of cultivated earth that revealed something extraordinary. These were among the oldest farmed soils on Earth, and they were still structurally intact, still readable after 6 millennia. At a separate site, researchers reconstructed a 2,000-year timeline of continuous paddy cultivation and watched soil organic carbon climb decade after decade. No factory built this. No company sold it. Generations of farmers fed the soil with rice residue, straw, and fermented wash water, and the soil recorded every gift. The knowledge of how was rarely written down. But the earth itself was the document. So what happened to that knowledge? In 1909, a German chemist named Fritz Haber pulled nitrogen out of thin air and synthesized artificial fertilizer. Within a single generation, the slow, patient practices of feeding soil biology were buried under bags of nitrogen, phosphorus, and potassium. A $230 billion industry was born on one quiet myth that healthy plants come from chemicals you must purchase, not from life you can cultivate for free. 3 nutrients out of 17 sold back to you every season. The garden was alive once. The industry sold you the silence. Here is what the research has quietly confirmed. Earthworms, the single best indicator of living soil, do not actually eat your kitchen scraps. They eat the microbes that colonize those scraps. A 2025 meta-analysis published in Science Direct, reviewing dozens of controlled studies, reached a striking conclusion. Earthworms function not as predators of soil microbes, but as mutualists, and their presence increased bacterial abundance in the soil by 16.5%. A Frontiers review titled "Earthworms Building Up Soil Microbiota" documented the same loop. Feed the microbes, and the worms multiply. Multiply the worms, and the soil transforms. Rice, in 7 different forms, is one of the most powerful microbial signals you can send underground. Here are the 7 rice tricks they never told you about. Trick 1. Cooked rice. The fast-acting worm magnet. Plain cooked rice is the quickest biological alarm you can sound beneath the surface. The moment it hits moist soil, bacteria and fungi swarm the soft starch, and within 24 to 48 hours, a visible microbial bloom takes hold. The worms do not come for the rice. They come for the feast of microorganisms growing on it. This is the mechanism the Science Direct meta-analysis described directly, that earthworm populations rise in lockstep with the microbial biomass available to them. You are not feeding worms, you are setting a table that microbes cover, and the worms arrive for the meal. The effect is fast, but it is also short. Cooked starch is consumed quickly, which is exactly why it works as a rapid trigger rather than a season-long supply. Scatter 2 to 3 tablespoons of plain cooked rice per square foot, press it lightly into the soil surface, and cover it with a layer of mulch to keep it shaded and moist. Repeat every 2 to 3 weeks during the growing season. Within days, you will notice the soil softening and the worm castings appearing where there were none. Trick 2. Crushed uncooked rice. The slow-release underground feeder. If cooked rice is a sprint, crushed raw rice is the marathon. Dry starch breaks down gradually over weeks rather than days, releasing a slow, steady stream of food that keeps the microbial population, and therefore the worm population, active far longer than a single bloom. Where cooked rice spikes and fades, crushed raw rice holds a low, constant hum of biological activity through the entire season. The reason is structural. Uncooked starch granules are dense and crystalline, and soil microbes must break them down enzyme by enzyme. That slow digestion is precisely what makes it a long-lasting feeder rather than a quick flash. Lightly crush dry rice with a rolling pin or the back of a spoon, then work 1 to 2 tablespoons per square foot into the top 2 inches of soil. Cover with mulch. Applied once a month, this becomes the quiet baseline that keeps your worms fed between the faster pulses of cooked rice. Trick 3. Rice bran. The microbial accelerator. This is the concentrated, upgraded form of rice that most gardeners have never heard of. Rice bran is the outer layer stripped from the grain during milling, and it is far richer than whole rice in easily accessible starches, oils, and nutrients. It is the foundation of Bokashi composting and a cornerstone of regenerative farming systems across Asia, precisely because it feeds soil microbes faster than almost anything else you can add. The research is consistent. Reviews of Bokashi systems describe rice bran specifically as the carbohydrate source that drives explosive microbial growth, with documented increases in phosphorus-solubilizing bacteria, nitrogen-fixing bacteria, and beneficial fungi. A published review of Bokashi as a soil amendment reported improved yields in maize, rice, soybean, and shallot in marginal soils following application. The bran does not just feed plants, it builds the microbial workforce that worms then graze upon. You can use it 2 ways. Lightly work 1 to 2 cups of rice bran per 10 square feet into the top few inches of soil. Or make a simple bran tea by fermenting 1 cup of bran in 1 gallon of water for 3 days, then apply it as a soil drench. It works powerfully in worm bins as well, where it can visibly accelerate reproduction. Trick 4. Fermented rice water. The liquid microbial booster. Here is the trick that costs you nothing, and that most people literally pour down the sink. The cloudy water left over from rinsing uncooked rice is loaded with surface starch and wild microorganisms. When you let it ferment, it transforms into a living microbial inoculant, rich in bacteria, amino acids, and plant-available nutrients. You are turning a waste product into a weekly soil tonic. The cloudiness itself is the active ingredient. That milky rinse carries both the starch that feeds microbes and the native organisms clinging to the surface of the grain, which is why fermentation wakes it into something biologically alive. Rinse 1 cup of uncooked rice in 2 cups of water, saving the cloudy second rinse. Let it ferment in a loosely covered jar for 2 to 3 days until it turns faintly sour. Dilute it 1 part rice water to 1 part fresh water and apply it weekly as a soil drench around your plants. It feeds the microbial layer directly, and the worms follow the microbes upward. Trick 5. Fermented rice and milk. The hidden lactic acid secret. This is the microbial technique most gardeners never learn, and it comes straight from Korean natural farming. By fermenting rice wash water and then feeding it with milk, you cultivate a powerful, selective culture of lactic acid bacteria, often abbreviated as LAB. This is not a vague brew, it is a targeted inoculant that floods the soil with one of the most beneficial bacterial families in regenerative agriculture. The science behind it is specific. Lactic acid bacteria produce bacteriocins, which are natural antimicrobial compounds, along with organic acids and enzymes like proteases and amylases that break down complex matter into forms plants and microbes can use. Korean natural farming practitioners have documented these cultures suppressing root rot pathogens through competitive exclusion, while improving soil aeration and plant resilience. Lactic acid also chelates locked minerals, freeing them for root uptake. To make it, ferment 1 cup of rice wash water for 3 to 5 days until it smells sour. Then mix that 1 part fermented rice water with 10 parts milk and let it ferment another 5 to 7 days. When it separates into floating curds and a clear yellow liquid beneath, that yellow serum is your concentrated culture. Strain it, dilute it heavily in water, and apply it as a soil. Drench or a compost activator. Trick 6. Rice straw. The long-term soil builder. This is how traditional farmers built living soil for generations without buying a single product. Rice straw, the dried stalks left after harvest, has been returned to fields across Asia for centuries. Earthworms actively pull it down and break it apart, converting tough plant fiber into stable, lasting organic matter that improves soil structure and water retention year after year. The research on straw return is some of the strongest in this entire list. A study from the Rice Research Institute at Sichuan Agricultural University demonstrated that incorporating straw alongside soil microbes significantly increased organic matter, available nitrogen, and crop yield. A Frontiers study documented earthworms directly feeding on and dismantling returned straw, accelerating its conversion into soil. Research across China's paddy fields found that long-term organic return drove soil organic carbon up by 48% over recent decades. Straw is the slow engine that turns this season's residue into next decade's fertility. Use chopped or whole rice straw as a mulch, 2 to 4 inches thick, around your plants. At the end of the season, chop it and lightly incorporate it into your beds, or layer it into compost piles and worm bins, where it becomes both bedding and food. Trick 7. Rice in worm bins and compost. The population multiplier. The final trick ties the entire system together. Adding rice, whether cooked, crushed, or as bran, to your worm bin or compost pile turns it into a high-performance biological factory. The principle is the same one that runs underneath all 6 previous tricks. You are not feeding the worms directly. You are detonating a microbial bloom, and the worms respond by eating more, reproducing faster, and producing dramatically more castings. This closes the loop the meta-analysis identified. More microbial food means more microbial biomass, and more biomass means a larger, faster breeding worm population. The worms then concentrate all of that biology into castings, the single richest soil amendment a home gardener can produce. In a worm bin, add 2 to 3 tablespoons of cooked rice or a handful of bran per feeding, tucked under the bedding to prevent mold on the surface. In a compost pile, sprinkle crushed rice or bran between the layers to speed decomposition. These 7 tricks are not 7 separate hacks. They are one interconnected system, where each form of rice feeds a different layer of the same biological engine. But it survived. The knowledge never vanished into corporate archives or regulatory vaults. While the synthetic fertilizer industry consolidated into a $230 billion machine, a quiet network of rice farmers, Korean natural farming practitioners, worm composters, and stubborn home gardeners kept these practices alive through generations of institutional indifference. University research at agricultural institutes across China, Japan, and Korea confirmed what paddy farmers understood 6,000 years ago, that soil fertility is built by feeding biology, not by purchasing chemistry each spring. the buried Neolithic paddies of the Yangtze Delta still hold their structure after 6 millennia. Korean farmers preserved the lactic acid bacteria technique through decades when chemical agriculture was sold as the only modern path. And the humble bowl of rice wash water, poured down millions of drains every single day, turns out to be one of the most potent free soil inoculants ever discovered. Today, that science is accelerating, not because the industry permitted it, but because the science became undeniable, and because gardeners, tired of expensive products that fed plants for a few weeks and left the soil dead, started asking why ancient systems built fertility that lasted forever. The silence around these tricks is breaking. You can grow what they buried. Start simply. This week, save the cloudy water from your next pot of rice instead of pouring it out, and ferment a small jar of it. Scatter a few tablespoons of leftover cooked rice into one garden bed and watch how the worms respond within days. If you have access to rice bran, buy a single bag. It costs only a few dollars, and use it to charge your compost pile and worm bin. Then layer in straw as mulch through the season and let the worms do the slow work underneath. The total cost of this entire system is close to nothing. Cooked rice and wash water are byproducts you already create. Rice bran runs a few dollars for a supply that lasts months. Straw is often free for the asking at the end of harvest. Compare that to the $50, $80, or $100 gardeners spend each season on synthetic fertilizer that vanishes in the rain and leaves the soil more dependent every year. These rice tricks move in the opposite direction. Each application builds the biological baseline higher, so your soil needs less over time, not more. That is the precise reverse of the dependency the fertilizer industry designed. The richest soils on Earth were never bought. They were fed, patiently, with the things most people throw away. If this seed of knowledge was finally freed for you, subscribe to Hank's Gardening Journey and hit the bell. Every like and every share helps break the silence around what real soil science can do. The next secret breaks free soon.